Assalamualaikum warahmatullahi taala wabarakatuh. So this is the second session that we have for this course. So one of your friend asked me about a book. So this is the book that you can use for dynamics, recommended by the professors and the faculties members when they are developing this course, right? So I hope I answered that question. Um, so today we're going to look at the details on the kinematics of a rigid body, right? So I have given to you the assignment. Let me share um, my dashboard, my desktop. I think this is enough. Start sharing. Right, we're going to represent the bicycles with uh, a model of rigid bodies. Let's say this length is 1, right? So make it plane geometry or something like that. Maybe I should reduce the size of Z. I should see it from the plane view, right? I think that's correct. Um, Let me place it at the centers. Um, Minus 0.5, minus 0.5, 0, right? So that's the shape of the bike, right? So we're going to moving it to a certain locations. Let's say make it 10, right? And then we're going to make a circular motion. Um, right, so that make it 36, 360 times t, right? And then I'm going to animate the motion with animate, right? So make it 30 frames per second and make it move very slowly, right? So we have a bike that make a circular motion. Let me print screen that and then place it on pane, right? So the S coordinate system is based on the path, right? So that will be the S coordinate system. So we should know where the origin of this S coordinate system, right? You can place it arbitrarily because we don't know where it starts. So we just say that maybe this one at this location, right? Sorry, I still not get used to it to the the system, right? And that will be the s equal to 0, right? So if it is making a complete circular motion, and the final will be s equal to, maybe if you want to give it in meters, it can be 2 pi r, right? So let me write again, as final 2 pi r, right? So that will be the final positions for this. If we want to represent the motion of the bicycle in S coordinate system. So if we want to represent this problem in terms of X and Y coordinate system, so how we can doing it? Um, so what we need to do is to draw the axis of X coordinate system, right? So that will be the X coordinate system. This is the convention that we use normally. This one is X, and this one is Y. And for this case, the uh, the position vectors for the bicycle is given in that direction in X, and then the Y direction, well, is at 0. So just say that something like that. So you have to write it in that uh, form. Let me write it in the position vectors. Text pf r, right? So this one is equal to x, text pf, so that's the way that we're going to write the position vectors for the bicycles. So let's say this one is minus r cos theta, something like that. So you just get the value of x, the numerical values, and then the y values. And then if you want to write in the cylindrical polar coordinate system, right? So again, we're going to copy that portion, make it large, and the coordinate system for the R coordinate system start from the origin that you define, right? And then right, the student like to talk much, right? Macam-macam lah. Okay, let me finish with this. And we have to make the angular motion uh, from a line that we define, right? This one, something like that. So we have r there, and then we have theta there, right? So we just write. Yes. Asniza. Ya, apa ada apa Asniza? Talk. Cakap. Right? So that will be uh, the way that we going to write the punya tu. And then we have the R to represent the magnitude. So that will be the in a spherical polar coordinate system. Yes, more of Kamit. Apa dia? So that will be in the spherical polar coordinate system. This one will be in the Cartesian coordinate system. And this one will be in the S coordinate system. Right, any question so far? Yes, ni Muhammad Azamuddin asked about is cylindrical polar coordinate system 3D. Yes, it's 3D, should have a z-axis, but in our lecture we are looking at plane motion, and plane motion is 2D. So we just consider the radial and the yeah.